The next workflow I will walk you through is our data analysis workflow for determining impurities in our 5' capping enzymatic process using intact mass. This CQA is for mRNA, as the 5' cap will prevent degradation via exonucleases within the cell. But the enzymatic process to put the 5' cap on the mRNA can cause impurities, which can be detrimental to the effectiveness of the mRNA product. The data set I'll be using here is of a 25-mer oligonucleotide mix with the intended product Cap1 and its enzymatic impurities.
A typical experiment to determine the 5' capping efficiency would begin with an endoribonuclease digestion of the mRNA in question. Then, as with our previous workflows, the digested mRNA would be submitted to LC-MS analysis. However, in the data set I'm about to show you, the Cap1 product and its enzymatic impurities were artificially added to a 25 nucleotide long oligo to mimic an RNase H digestion of an mRNA, which would isolate its 5' cap. The capped oligos were then mixed in different ratios to determine the level of impurities that could be detected in a typical analysis. To summarize the study, the synthetic cap of interest, Cap1, had typical incomplete capping impurities added to the sample at 1 to 10, 1 to 100, and 1 to 1000 ratios. The TIC and deconvoluted spectra shown here are from the 1 to 10 sample. As you can see, there are two distinct peaks in the TIC, and while the peak marked with the circle contained many of the impurities as well as the product, two impurities were separated into the second peak marked with a square. Now I'll use this data set to show you how we can measure 5' capping efficiency using intact mass. First, let's set up the method. For this analysis, we will want to set up a custom deconvolution configuration using Bayes spray. Because we are interested in low abundance impurities, custom deconvolution is the preferred choice over auto, as we can focus the algorithm onto a retention time of interest and specific ranges for both the input m/z and the output mass range. Once we have set this up, we can then select our modifiers. Intact mass comes preloaded with a large list of modifiers, and they can be filtered by molecule type. If we scroll down to the mRNA section, you can see that there are many different cap types, as well as their enzymatic impurities. Once you've selected your cap of interest and their impurities, you can add them to the selected modifiers list on the right-hand side of the screen. Finally, in the quantitation limits section, we will want to set the mass spectrum percentage calculation to total response. By selecting this setting, intact mass will automatically provide your enzymatic capping efficiency percentage using the molecule percentage column in the results table. Now that our method is set up, we can process our analysis. And here are our results. In the results table, you can see the low-level impurities that have been identified by intact mass, as well as our intended product, this last line here. If we scroll over to the molecule percentage column, we can see that our enzymatic capping efficiency is around 95%. And that is a quick overview of our 5' capping efficiency data analysis workflow using intact mass.